Welcome to Houdini Python series. This is the continuation of copy AOVs for Arnold, where we are selecting the first node as a parent node and then the children nodes, which gives us the UI with list of AOVs present in a parent node, which is our first node, but it doesn't give any output for now. We will be adding the functionality and we'll check it. So we'll edit the tool. So to check what is the value when I accept, like when we select the accept button, to check with this we will print it out. So this is giving us a tuple, but we want to convert it into a list because we will be looping over it again and again, maybe only once. So for that, prior converting into a list, we will need to check if the value already exists. If this exists, then it should work. Print it out. See, if I select a value and accept it, it's giving a value of 0 as it's considering this as a list. So here if we look in our Arnold AOV, it, it starts with 1 and not 0. So what we will be doing is we will be adding a value of 1 to our existing number. To do so, I will use a for loop. If we print it again, AOV number, accept it. It's giving a value of 1. If we select multiple, 136. Now we will go to the parent node again and we'll check the value of the first index having the prefix AR underscore AOV. We will need to define the prefix. This was the AOV count. AOV prefix. We'll copy this again. To do so, like in the going in the parent node and checking all the parameters, as we already did in previous video with the help of looping and the help of parameters command, which is parent node in our case, dot get all the parameters associated with it and print it. If I just select now, uh, having some issue like a syntax error. Again, if we select the first value and the last first node and the second node, this is giving whole lot of information, but we only need the value for this, like ARAOV pixel filter and all. So what we will be doing is we will be using the module called RE, import RE, where this will help us we will be using re.match. This takes two values. First is the pattern value, it's called pattern. Like whatever we want to search, if I want to search a node over here, for example, in the child node, what I do is Control F and I provide the pattern to this node editor. In our case, it's child. So it gives me all the names having child and not other names. So the same way we will be giving the pattern to this, and then we will be giving the parameters. Okay. It will be used over here if re dot match pattern and then the name of the parameters, which is x dot name, and I also wanted to output as a name only and not the whole parameter thing, but we don't have pattern yet decided. To do so, we will be defining the pattern as search pattern. What we have to search is we have to check with the prefix plus we have the number. For example, this. If I print it out and check our search pattern, as this is string and this is number, I will just convert it into a string value so it doesn't throw errors. So this is giving me the output for the ARAOV 2. But for searching the pattern, if I use this, it's giving me nothing because we have to use the wildcard. For example, um, if I use find node in node name and put star or asterisk, it will give all the nodes. The same way I want to look through all the nodes. For example, ARUV star 2. To do so, in this pattern, we have to add the star, but this even takes a period or dot and star. When I will apply this and check, so it is giving me all the value with ending the 1 and starting with ARUV, but it is giving me even the 10, like even 10, even 11, even 12, like this. But I only wanted the value associated to 1. So to do so, that it should only have the value of 1 and not 10 or 11 or any of the value or number ahead of it. To do so, we will be using a bracket, and I'm just saying any value which is not digit, like ahead there should not be any digit. For example, AOV number dot one. So this star should not have a digit value. This is the indication that it is not a digit value. Uh, Sorry, this, and I should say this. This is a symbol of not. It's similar to saying the condition, and this is the symbol for digit. This is not a digit. Okay. So if I search it again now, it will again give us the same value, I guess. Yeah, a bit less because we are constraining it to the value like it should not be a value ahead, but the values can be behind like this. So to do so, like we have to end our search pattern. We have to add a value like $1. This will let the pattern know to stop the searching if we receive the value like AOV number, then anything other than digit, the value AOV number. In our case, this is not AOV number, sorry, it is prefix, AOV prefix. If I apply it again, so now it is just giving us the value of 1, nothing else. So till now what we have done is we have received the index value over here. Then we went through all the parameters in the parent node and searched with the help of prefix called ARAOV and the index value. We received all the values like ARAOV label with the index value ARAOV LP, the index value plus 1, like that. Then we will be going through this and checking all the like data in this. For example, if I go to the parent node, what is the value of AR AOV label 2? It is P. Here, if I go AREOV EXR layer name 3, it will provide a diffuse all name. So this we have to store in a list. First we will store this AOV keys, as these are just the parameter, but the values are different. We'll print it. Again we will just for loop it. X for X in AOV keys. This will just give me the same thing. But what we have to do is we have to take the parent node again, to make it big, and to increase the size we can just click Control plus on the keyboard. Parent node parameter, then we will be providing the value called X and evaluate it. Accept it again, and this will even increase the value over here. It's fine, not an issue. So this is giving me the value of this label, then it's 0. So where there is no value, it's 0. These values are also recorded over here. So it will just give me in a list of each AOV which is selected. If I just select it again, and if we check the diffuse, because there we even added one more um, like value to this, accept it, diffuse all. So this, okay. So this will be our AOV values. Now what we will be doing is we will be sending this value to our child nodes. For that we will be looping our child, like we have multiple child selected. In this case I selected just one, but if we have more child to it, we will query the AOV count to this to a child node, and we will add one more number to it and set it. So it will give us one more value. For example, it has a count of 2, but we have to add the value over here. So we will just increase the value to 3, and then we will apply the values. Go for child nodes where I have selected it here. Child nodes, yeah. Child node in child nodes will query the value and print it. Okay. To do so, I will just write child AOV count dot parameter. What is the parameter? It is AOV count. Evaluate it, and then we will add 1 to this. Copy this. What we can do is we can give equal to child AOV count plus 1, or we can do is we can simply do plus equal 1, which is equivalent to that. Now we will add 1 to this. Here again I will write, we'll copy this exactly. We'll do a set. So if you check now, this is the value which is given. Now we have to fill this. To do so, we will need to modify the value which we already received, which is ARAOV label index value plus 1. So which this is a parent thing, like the parent data or parent, uh, what we called in Houdini, parent keys, AOV keys, and we'll change it to the child AOV keys by changing the index value plus 1 to AOV count. To do so, we will be using print node again. I will delete the, yeah, done. Print. We will loop through AOV keys, but here also we will need to search and replace. To do so, I will just make it a bit. If dot match the search pattern which we already has with the value of x, I will just pause our set command and accept it, applied. Master and child. Then so it is giving us all the values. Here we have to replace the 3. Coincidentally both are 3 now. But if I just select other than this, huh, we have to replace 1 with 3 in short. So what I will be doing is I will split the value x dot split. This is the command to split the string. Split it with the AOV number which we already has, and if I just print it again, this gives me a list where the second value is what we have removed and the first value is without any numbers, but we want only the first value. We'll apply it again. As this is a list, wait, as this is a list, now we will take the first index of it. uh, let's check. Now we will be adding the value of 3 in our case because we already has two AOVs in this. So we will add 3 to each. To do so, I will just add plus string value of this child count AOV and apply it. That's that's it now. This is called in our case is AOV keys. Child AOV keys equals to. Now we'll just set the uh, values thing, AOV values. In most of the cases, it's same. Like in 100%, it will be same, but the counts this list and this list. But I'm just making it safe. The child keys counts should be equal to the value keys. Print both things. 28, 28. Now we will just correspond the list and will apply it. This will be easier, where I will go through all the AOVs. Child AOV keys, where is it? Here we will need to index each value. Like this is the value of 0, 1, 2, 3, and the same like value we have to take it from the AOV values. The 0 value should be in front of it. So we can do is we can define a variable I equals 0, and we will just do I equals I plus 1 or plus equals the same, and we will correspond these values. I will just take the AOV values, index it with I. I think it is a bit confusing, but let's see. So this is giving me all the values. Like what it is doing is, for example, if we have a list called A equals to A, B, C, and the second list B equals to 1, 2, 3. So these are all the things. This is our key thing, and this is our child thing. So what we are doing is we are taking this and connecting with this, taking the B value and connecting with 2, C value with 3. That's it. So now is the time for connection, where we will use a child node again. Dot parameters. The parameter is child AOV and the value is set AOV values with the index value. But it won't work if I just comment the adding count value. So for example, let's see, try something which already has one value first. For example, P. This is added. This is our child node where P is added. Now if I go in the master again and check, we'll add a diffuse value. Okay. So irrespective of anything which has changed, for example, the ID, if I change it to unassigned integer, it should work the same way. Yeah. But lastly, one thing I wanted to do is if I have a disabled value, it should let me know which is a disabled value. For example, in our case, the sheen direct, if I keep it disabled and if I check, there is no difference making. So to make a difference, what I will be doing is I will just write a disabled over here to let the user know that this AOV is already disabled in the master or the selected node, parent node. To do so, we'll be going through this parent AOV labels, and here only, like this is only going in the choices. So here only we will need to add those things. To do so, we will be using for I in range of labels print parent node dot parameters. So here we will need to check what is a node, like what is a parameter to check if it's on or off. This is AR enable AOV. Till now it is everywhere AR AOV, but here it's AR enable AOV. So we will define it as AOV enable equals to AR enable AOV. Copy it out. We will use a string with this value +1 and evaluate it. This will give us the value of 0 or 1 or true or false, which we can check with this. List object cannot be interpreted as an integer, which was the line number 28 and 63. Use a length command for this because that is we need to know the count, or else we can use the count directly, because this, if I check, this is a list, but there is no number to this, a count number. So we can use a length and we'll comment out everything else. It is giving 111. Last one is 0 in the parent node, so it's giving the value of 0. Other than this, we can even use the value of count. Both are same, which will be as enable check. If enable check equals to 0, we will change the label thing, the list, with the index, which is I, equals to the label index, and we will just write disabled. Let's check how it comes. So at least this will give the user to understand that the node is disabled already, and even though if he wanted to copy, it will be copied, but it will just let him know. So we'll remove this comments. Yeah, thank you.